So in our first lecture, we identified what Bernoulli trials were, and now we're going to introduce the first of two of the models that we talk about in chapter 17, and we're going to revisit an older problem. Well, I just kind of gave you the, here it is. There it is, just making sure I'm on the right slide. And we're going to bring back our trading cards, our athletic trading cards here, and 20% of the boxes contain a picture, a card of Tiger Woods, 30% David Beckham, and then 50% a picture of Serena Williams. So the question for this first model, as you saw, is called the geometric model, but we'll get that in the next slide, is what is the probability that you would get a Tiger Woods card on the fifth box purchased? This one doesn't really need a particular model. There's nothing fancy about what we're doing here. In fact, if you can kind of comprehend that, our probability of success, in this case, is 0.2, which is finding a Tiger Woods card. That's what we're looking for. And our probability of failure, which we call Q, is the complement of that. These are Bernoulli trials. You either get it or you don't. And what we would probably recognize is this is a multiplication problem. This is a multiplication property problem. So we'd say, all right, well, the likelihood that we would get on boxes 1, 2, 3, and 4 something other than Tiger Woods is 80%. And then getting Tiger Woods on the fifth is 0.2. 0.8 times 0.8 times 0.8 times 0.8 times 0.2. We got about an 8% chance that we're going to get Tiger Woods on the fifth box purchased. That our first Tiger Woods occurs on the fifth trial, so to speak, if we call buying boxes trials. And that, as we already kind of showed you, is the geometric model, which is a model that allows us to find the probability that the first success will occur on or by a particular trial. Our calculators are going to come in very handy with this, even though for a lot of these types of problems, I don't know if you're actually saving any keystrokes by using the geometric function on the calculator, but on some problems it actually would help, right? And it's very straightforward. We practically know it already. We're specified by the parameter p, which is the probability of success. When it's specified by a parameter, that's the same way that when we're talking about the normal model, where we have a mean and a standard deviation, and that's how we calculate a z-score. Those are the parameters of the normal model. What information do you need to have in order to use this model is essentially what we're looking at. All we need to know is the probability of success, because it really is pretty basic math. So if we had the model represented by geomet p, or in this case geomet 0.2, and we have the probability of success is 0.2. The probability of failure is, in our book, we call it Q. In the formula sheet on from AP Central, it's 1 minus P. So just recognize that those are interchangeable. X is the number of trials until the first success occurs. So just like we had there, when we were saying, what we did was the probability that X would be 5. And what did we do? We multiplied 0.8 by 5 minus 1, or 4. We multiplied 0.8 4 times, rather, and then multiplied it by 0.2. Right? And that got about 8%. That's all there is to it for the geometric model. If we're looking for the probability that something happens on this particular trial or on that particular trial, we are searching until we find our first, and then we stop. That's what we do. And that's a pretty straightforward question. That it happens on trial 4 or 7 or 10 or whatever. That's what we would do. And mathematically, we really don't do much differently, even as the questions might change, right? So say what is the probability that the first tiger card is found in one of the first 3 boxes purchased? Okay, it's a little bit different, but they're still doing the same thing. We just might have to do it a little more than just once. What we're really looking for is, we're still using a geometric model of 0.2. That's our basic formula. And if we're looking like this, we're saying, okay, the probability that our first success occurs by the 3rd trial. So that means it's going to occur on trial 1 or trial 2 or trial 3. There it is. We're saying or, so we're adding probabilities. And so the probability that it happens on the first trial is 0.2. It's the likelihood that we get any box. And then the probability of that it's on the second is 0.8 times 0.2, and so on and so forth. Easy enough to show that, and again, it's easy enough to calculate that, to be honest, but the calculator will help you once we go over that in class. Right? So if we said by the 3rd, we'd have to account for all the ones up to and including whichever one we're looking, or however the wording is, and be real careful about the wording. Before or by are 2 different things. Before the 3rd one would not include the 3rd one, but by the 3rd one would. So you want to be really paying attention to the phrasing of the question, because it could affect it. Could affect it a little, could affect it a lot. Right? So you want to be careful about that. We can also use this if we are saying, we could also take this process here and say, what's the likelihood that it falls after the 3rd box? Right? So if we wanted to say, what's the probability that the first Tiger Wood card occurs after the 4th box? Well, since we don't really know, there's no finite number of trials, right? After the 4th box, actually, I should not include the, I shouldn't include that, should I? We would take and find the complement and say 1 minus the probability of x is less than or equal to 3, and everything else would be 4 and up, right? So we would take and find that. So it's about 0.512, right? Based on that. Okay, we'll get lots of practice with this in class. So don't worry if it's not clicking instantly, but there really isn't too much beyond these types of problems here, that if you were looking for the particular calculation or probability. And then the only other thing that comes with both of these models is this idea of how many boxes would we expect to purchase before finding a Tiger card. After that last unit, we should be thinking, when we hear the word or the phrase expected amount or expected, that should be our mean. So for both of these models that we're covering here, the geometric model here, and then the next one that we're going to cover in the next lecture, we're going to be able to find a mean and standard deviation, which should probably give you some indication that the normal model might come into play at times. If we're to find the expected amount, right, the mean of that would be 1 divided by the probability of success. Right? 5%. We would expect by the 5th box to get a Tiger Woods card. It doesn't mean that we're going to. It just means that's what we would expect. If 20% of them contain Tiger Woods, right? 20%. If we reduce that, it comes down to 5. Right? The standard deviation is a little less intuitive. Right? The standard deviation is the square root of Q divided by P squared, or, which is also equal to the square root of Q over P. Right? Either way, that's what I just wrote is how the formula sheet has it. Okay? And that says we've got a standard deviation of almost 4.5. Right? So yes, we would expect it by the 5th, but we probably wouldn't be too worried if we don't get it by the 9th, right? Because that's within 1 standard deviation, if they're normally distributed. Right? So our first model, our geometric model, deals with the probability of finding our first success on this trial or on that trial, or by this trial or after this point, anywhere along those lines. Right? We will get plenty of practice with this, as well as get the calculator input when we're meeting in person. After this lecture, give these a try. Page 402, number 9 and 11, please. Number 9 and number 11. Those you should be able to try now based on what we've covered here, right? Like I said, we will get lots of practice on this in class, lots of work days with this. Well, maybe not lots, but we'll get work days with this, and we will go over the calculator input as well. Please let me know if you have any questions. I hope this helped.